Vector database versus traditional vector data versus traditional relational database. The main difference between a modern vector and traditional relational database come from the type of data they are optimized for. While a relation between is designed to store structured data in column, or vector database is also optimized to store unstructured data. Example like text, image, audio, their embedding model. You can see it. Because vector and relational database are optimized for different type of data, they are also different in how is stored. Retrieved in the relational database, data is also stored in column and retrieved by keyboard matches in traditional search. In context, to also store original embedding enable efficient semantic search, because vector search can semantically understand the search term. It doesn't rely on retrieving relevant search results based on the exact matches. Here you can see the reference semantic search, like question like dog, cat, wolf, and the semantic search animal, and this will be question. And for example, imagine you have a database that store geographic question, and you want to retrieve all questions that contain an animal. Because search in traditional database relies on keyword match, you will create a big query that can query all animal. Example content dog, cat, animal, wolf, and you can simply code a query of animal. Here you can see, for traditional database we need to find more things, like we need to sort dog, cat, any parrot, anything like that to get an answer. But in semantic search we simply type animals, so it can give us the animal with their question. Because most of vector database do not rely on the vector store embedding model, but store them together with original data. Not only capable of vector search but also enable traditional keywords from like web type, even support hybrid search capability that combine vector search with keyword search. Now come to the vector database versus vector capable database. Today many existing databases have already enabled vector search and support vector search. However, they don't index vector embedding, which makes the vector search slow. Thus, an advantage of native vector database of vector capable in their efficiency in vector search due to the vector indexing. Similarly to vector database, vector libraries are also enable fast vector search. However, vector libraries only store vector embedding of data objects, and they store them in a memory indexes. The result in a two key difference of the ability. The indexes data is immutable, and thus no real-time update are possible. Scalability: most vector data libraries can't be queried while importing data, which can be scalability constraint for applications that require important of million or even billion of objects. The vector library is a great solution for applications that with a limited static snapshot of data. However, application requires a real-time scalable semantic search. At the production level, here you can see concept of vector database. Vector database versus vector graph database. A graph database stores data in a node or is represented entirely their replaces relationship. It optimizes for querying connection and pattern with the data, making it powerful for network, social, and recommendation system. A vector database, on the other hand, index, store, and provide access to the structure or inner structure. Example: text or image alongside it. Vector embedding, which are data numerically represent. It allows user to find retrieve similar object quickly at a scale. In production, vector database versus vector store. The vector store is a lighter system or library designed especially to store and redirect vector embedding. It focuses more on managing vector and support basic operations like indexing and querying. A vector database, on the other side, only store retrieve vector embedding but also offer comprehensive database functionalities such as distributed strong scaling, security support for the complex query. Vector database FAQs. The section answers some common question about vector database. Why we need vector database? Vector database are essential for efficiently managing and searching high dimensional vector embedding. They are real-time, accurate, and similarity search, which are recorded in the native of AI stack. So we want to find any information that are page or book that are in a million or billion page, which make it in a real time accurate information that is only given from a PDF. So why use of vector database? Vector database have become a critical component in the AI native app stack, particularly for the managing vast amount of unstructured data that our organization generates such as image, text, and audio. Unlike traditional database, which struggle with unstructured data, vector database efficiently stores sounds and analyze the data by leveraging high dimensional vector representation or embedding. This capability is particularly beneficial where the ability to retrieve relevant information quickly and accurately is critical. For example, in recommendation system of NLP vector tags, vector database enable business to unlock valuable insight, leading more informed decision making on improved. Business to find product context or information that closely match user query that is not only improve user experience and engagement but also drive customer specific personalization. Vector database scalability and performance are crucial as a business grows and data volume increase. The data base are optimized for handling large scale high dimensional vector, ensuring the data retrieve and remain fast and accurate even at scale. The scalability is vital for AI applications that require real-time data processing such as chatbot, fraud detection, and other interaction AI system. Why this is matter? Additionally, vector database is integrated seamlessly with an existing AI workflow, including LLM architecture framework, embedding model provider, and interface engineer. This integration simplifies the deployment and scaling production level RAG application, making it easier business to harness AI full potential by providing specific infrastructure for storing and retrieving vector database, reduce the complexity and cost associated with the AI deployment, allowing organizers to focus on innovation. So delivering personalized experience to the customer. How to use a vector database? Store vector embedding in the database, index them to for efficient retrieval and perform similarities such as to find most relevant data point. How to choose a vector database? Similarity criteria for a vector database are such latency, memory, footprint, as object count, cells of recall, retrieval, relevancy, code efficiency, and integration capability with existing AI tools such as AI language model, embedding model summary. This article explains the vector database, type of database, index, store, and provide structure. You can read in the internet. Okay, bye.